can probably start. And thank you for all of you making to this room. And since it's so many of us, we can sit closer and have a nice, cozy discussion about things, about the topic. My name is Anton. I work for JetBrains with the IntelliJ team. And today I'm going to talk about somewhat work in progress that we are doing over several releases already for supporting different persistence technologies. And the support is not just about supporting some framework, it actually spans multiple technologies, how you combine them together. And in Spring projects, it's especially visible because Spring is the integration framework and you use many different libraries together. There are a lot of moving parts. And tell me, how many of you are using IntelliJ? Just everybody. I expected, but you never know. You never know. There is always someone who is using Vim. This time, no one. But anyways, so I don't really have slides. I will have a lot of demos, and I hope we'll have like. Don't hesitate to ask questions. You know, comment something that I'm wrong. You know better, and. You have used something that worked for you better, just let's have a discussion and see. Maybe I can learn something from you as well. That's the only slide, right? Very important question, dark theme or light theme? Light theme, dark theme. Dark theme doesn't work on this projector, you wouldn't see anything. Well, anyways, if you didn't know that you can switch themes quickly, you can do it like this, right? Boom. But sorry, we are going to proceed with the light theme. So what I'm going to do is I'm going to demonstrate to you a project where I'm going to start adding things from scratch. The project will have no code in the beginning, but I have the full scenario step by step in this GitHub repository if you want to check later. It's there. There are like 10 commits basically. And we will slowly go through them. We probably will not see everything, but my point is that we are going to explore some of the functionality of IntelliJ that supports you with the different workflows, right? So the idea for this demo is that, well, I have this project here, and I will actually clean it up for you so that no code is there. We would have no database migrations. We have some dependencies in the configuration file here, and I'm using two databases. So the decompose.yaml is just for me to start the databases in Docker environment, and some property files that properties that we will explore later why they are needed. So we don't have migrations, we have clean application, we have the runner component that we probably don't need right now. Everything's clean. And it all starts from a SQL script. So imagine like I have an empty project, I have a SQL script that someone prepared for me. They have put it into version control and said, okay, this is the database that we have to work with, some SQL script, right? Have you played a game called Factorio? Right? Nice game. I discovered it actually a long time ago, but I started playing it a week ago, and I thought, this is like a nice thing. And, well, this database models the Factorio domain. Items, machines, so if you have played it, the schema will be very familiar to you. So what do we do? Like, what would be our first step? We have SQL script. We want to create the database schema, obvious, right? So we can connect to the database right here. I actually have two instances right now. One is sort of the production legacy database that runs. We don't know if anything is happening in there. We can just verify that there are 41 tables. And just a second, yeah. But assume it's a production database. It's frozen. We are not working with that. We have to work with our development database that is empty. And, well, we can just execute the script and see what happens. OK. Actually have to run it. Yep. So it's executing the statements, creating the tables, populating the data. There is some seed data. Let me see. Like if we scroll down, like there are some tables. Just a second. Bullet print, modules, and here comes seed data. So the file consists of two parts, the DDL and the data itself. So what do we have now? We have tables. We have 41 of them. We have some sequences as well. So that's the legacy database. We don't really know anything about it, or we assume that we don't know anything about it, why it was created this way, why the relationships are in this way, and so on. The next step for us would be to somehow start building the application on top of that. So we are in the database first scenario. The source of truth is the database, right? How do we do that in IntelliJ? Two main technologies in Spring projects. We have Spring Data JDBC, we have Spring Data JPA. Right? Who is using what? I didn't ask like which one. JDBC, JPA. So JPA is more popular. I assume, because when you ask some AI agent to generate the persistence layer, it usually generates JPA without asking, right? OK. And by the way, I asked in the poll for this talk, I asked what kind of migration tools you use. And most people answered Flyway, but it's only one more than Liquibase. So it's always 50-50, I would have guessed. Anyways, let's start with JDBC. Even if it's not so popular as JPA, but at least we will see how we can support that in this kind of scenarios. So in the pom.xml, currently I have JDBC dependency. And what I can do here is click on basically on any node. Yeah, like here, anywhere, and ask it to create the JDBC entities. I could do that for all the tables, maybe. Although we will not work with all of them. It doesn't matter too much. Of course, we can explore what exactly is mapped and how, but just assume we are not into the domain. We haven't explored all the details yet, but let's just run it. So it runs, creates some entities. It will be, well, more than 41, because some of the entities have complex keys. And there we have a flat structure. What would you do next? What would be your step when you have done this entities generation? There is a logical step that you want to make, is that somehow group them, right, into some logical domains. And it's very hard to actually intelligently recognize what part of the database should be mapped on which package and somehow offer it to you. What would be your solution to this problem? Don't hesitate. It's AI, right? It's AI age, right? We can do that with AI. Why not? We can probably do something like this. Open some agent, whatever you want. Maybe let me do that with Juni. I like this one more. And ask it to analyze. Let me even zoom in a little bit. Analyze entities in the, what was it, org example, Spring IO package, and why is it like, what's happening in here? Yeah, and group them logically into domains, create new packages, and move the entities accordingly. So what I'm doing is the style here is like do something, but I'm still pretty directive in my flow. Like what I'm telling it is that, well, you have to create the packages. Like I don't know how you group them, but please do. We could probably wait. I don't think it will be very fast right now. Yeah. Okay. Actually, it's doing something. Anyways, probably will take a couple of minutes. It's not the point right now that we can see the result, but are you using agents in this way? Anyone? Yeah? Good? Does it work for you? Like, sometimes? Sometimes? Yeah, let's see if it does anything. It's not directly related to the technology support in the IDE, it's just interesting to see how agent will cope with that. Will it be able to actually group things? So it tries to somehow declare the domains, right? Tries to figure out the domains. And it even created some kind of scripts for itself. 43 entities. Okay, so it actually started moving stuff, right? Under blueprint, there will be blueprint package. Where is it? Let's see. Okay, so it actually created even a Python script to do that. So there will be player package, factory package, production package, power, logistics, defense, research, map, blueprint, and alert. So some kind of a logical structure there will be created, yeah. And well, my expectation was that it would create some core packages as well, or maybe to somehow look into the seed data, because the file is there, and it could actually look it up and create packages according to these things, but they're ASCII art, and it probably just didn't recognize that. But it would have been possible. Sometimes it's happening. Not exactly my structure, but, well, it's something to start with, right? Well, anyways, it was a nice sidekick to this project, but we have to explore something else. We have to explore the relationships between the generated entities. For instance, factory and a machine. Let's go. So we have a factory. It has all the attributes. And my assumption is that factory consists of machines. And if you look at the entity, there is no reference to the machines. Well, something didn't really go exactly as I expected. And if I look up into the machine, it says that there is a reference to the factory, right? So, and if we are in the JDBC world or Spring Data JDBC world, we can probably recall what the experts are saying about DDD and how the entities should be structured. Maybe there should be an aggregate, and the main aggregate maybe should be a factory, and then you shouldn't be reaching from this like child relationship into parent relationship. So you shouldn't be like calling from machine to the factory. It should be vice versa. From factory, you should be able to navigate to the machines. So maybe we should generate those entities somehow in a different way. So let me generate only the two entities that we are currently interested in. So factory and machine. Generate JDBC entities, and let's explore this dialog right here. So if you want to get something exactly the way you want to get it, you actually have to analyze, like, what's in there? Surprise, surprise, you have to read the code. So if we explore the factory, we can see that there are some references, and one of the references that we are interested in is the machine, right? So machine. So it has to be a set of machines. If we go into the machine entity, we can see that there is a factory ID. It's a reference, and we probably don't want it to be a reference. We want it to be a basic type. So let's make it a basic type. And this is the structure that I want to get. So, OK, great. So now if I explore it, I see, OK, there are machines, a set of machines. It's a mapped collection. Goes into maps to the column factory ID for the machine entity, right? Great. So we don't have the factory reference in here, but we have just the factory ID. That's kind of a learning moment for us, that we have to explore the relationships before we actually generate something. And it's very hard to assume things from the tooling point of view, that which way does the user want to generate something. We can tailor some reasonable defaults, but it also is not very predictable which way you select the entities. Like, are you generating just one right now, or generating the next after, or you're generating both at the same time? So there are so many different combinations, and well, it is what it is. The other example that we can use here is adding the JPA support into the project. Let's say we add JPA, reload the project, and now in the database view, we could select, let's say, factory, machine, item, the core tables, and there is a receipt and receipt ingredient. And let's generate the JPA entities instead. So JPA, and let's this time explore exactly how we want to generate those entities. So factory needs to have the reference to the collection of machines. We want the item to maybe to have the recipe relationship. Machine is fine. It can have a reference, actually. Recipe, one-to-many relationship to receipt ingredients, and recipe is right there. So we are done. OK, so we have now the JPA entities. Great. So let's explore them for a second. There is the set of machines. There is a reference to the machine as well. We can navigate to the database view. So far, we are still treating database as a source of truth. So if we are making any changes, like, for instance, adding a column, for instance, alter table, and I just execute the change right on the database, right? So update the machine table by adding the status column, and there will be a default value. So let me run that. We have changed the schema, and our entities are out of sync, right? And there's some logic that the machine should be active only if the assigned recipe ID is not null, right? So if it's null, then it should be idle. So if we go and explore the database, the machine column, or machine database, machine table, here they are. We have a couple of idle machines, and others are active. So through this kind of changes, if you start thinking about your projects, when you use database migrations, would you do changes directly into the database and then generate the migration files? Or would you go and change the code and generate migrations? Which way? Like the first way, going directly into the database and making changes, right? And then manually creating the migration files, right? Would you do that inside IntelliJ, or would you do that somewhere in some command line tool or some external tool? IntelliJ, yeah, the best. Anyways, So there are different flows, right? And if you start multiplying those different flows by the number of technologies and the number of artifacts that you have in the project, it becomes combinatorial, basically, how many different workflows you have to support. And that's one of the things, that's one of the reasons I'm doing this talk. I want to get the feedback from the audience, which workflows make more sense for you. Okay, so what do we do right now? We have changed the database. We have out of sync model with the database. So if we go into the factory or into the machine, we have the new column in there. We need to add that. Or technically, we could start just typing in here and say that we need a status field, status, and the generator detects that this is the entity that is mapped onto that table. Apparently, there's a new column called status. We could just generate it for you based on the metadata from the table. Now, let's think about the logic a little bit. So yes, we have the database column is a string, a varchar in the database. But the logic of this column is rather not just a random string, but it's a status. Status is active, status is idle, status is blocked, whatever else. It could be some enum in our enumeration in our application, right? That's almost a poetry. So what could we do? In fact, there is a wizard that somewhat helps with this kind of situation. So create entity attributes from DB, and then, well, it detects that there is a change in the database that is not mapped into the entity, and we can see that it's a basic type, of course, but it could be an enum, and it offers some kind of default name for it, technical information that it could derive from the name, so it thinks it's a status type, but maybe we want to do something else. We want to, let's say, machine status, something like this, and yeah, and do that. So now we have machine status that is of type string in the database, of course, and then there is an empty enum that we can probably call active, idle, blocked, and so on, like according to our application logic or business needs, whatever. So we have this mapping. Now it should just work. The old getters and setters can be dismissed. Great. At this point, we are starting to go deeper into the application logic and start maybe developing something. And at this point, this is a turning moment that probably you would start going into data application first workflows, so that you start changing the application code and then adjusting the database code with migrations. At this point, we don't have any migrations, but how do we add migrations now into the migration support into the project? First of all, we have the legacy schema, right, somewhere in the SQL files. But we could just use that as a base migration and say that this is our base, and whatever we do after that, we could incrementally build on top of that. Or we could approach it slightly more structurally, because, well, this SQL, currently, this SQL script doesn't have the new column that we just introduced into the database. Oh, surprise. What do? We could, instead of using this script, we could actually go into the entity and say, generate Flyway init migration, like this, and tell it to generate it from database, not from the model. So there are two kinds of migrations or ways of generating those migrations. If we ask it to generate from the model, it will probably just drop 40 of our tables and generate only the migrations for the entities we have in the project, but we obviously want all of them. So Let's do that. Yeah, so we have this many tables now. Init, SQL. And let's put it somewhere into a more meaningful place. Let's say database under the migrations. Good. What I see here is that it's managed to create the sequences in the script, but I know I don't want them because they will be created automatically. This is something I have to discuss with the team so that we are smarter. We could generate it in a more smarter way. But now we at least have the init script. OK, we have an init script for the schema, but we don't have the data. And we cannot just use the seed data from the original script for the same reason, because we need the status field values in there as well. So what could we do? We, for instance, could create the empty file in here, v2 seed data, and go into the database and say, well, we probably just can use the data, the old seed data for the existing tables, right? Let's use that. But the machine table will need some adjustments. As you can see, a lot of the insert statements in the original script are grouped by some logic. Let me find this machine table. Machine table. Create table. Oh, insert into machine. Yeah. So if we look at this one, we can see that there are some explanations, right? Because the seed data models different variations of data that we will have for our final application. And it uses batch selects, which is interesting, and logical grouping for different kinds of machines. So we are missing the status field in here. So what could we do? Like, we could go into this machine table and say export into data, export data to file. But in fact, instead of writing to file, we could only ask it to generate the insert statements and copy to clipboard. So instead of using those statements right here, we want the new statements. So let's comment this out and say that these are the insert statements we want to use. So the problem now is that, OK, technically we have the data, but we lost the logical grouping that we probably want to have just for history, for reference, for better visibility into the project. What could we do? Why not use AI for that again? So if we, let's say we have different projects or different machines, let's select those statements and say group the insert statements for machine table according to the rules from the comment. And we would say that use batch inserts. Should be fine. So it's going to analyze a little bit, and we will see that the same statements will start to appear with the status field. And they're grouped logically, and it seems that it's repeating the same groups that we had in the initial data script, which is pretty convenient, I would say. Yes, it takes a few seconds. Yeah, it's finished. Great stuff. So we have that. Now, we have kind of retransformed our flow into the application first. We are ready to move there. We have Flyway migrations. We have the database. We can test our migrations probably and just drop whatever we have in the database. Are we brave enough? Yes, we are. Let's see. Let's drop that. Let's drop everything. We drop the sequences as well. Force refactoring. Yeah, I'm brave enough. Well, technically, I can just start the application and see if migrations run, or if I have the tool pre-configured, the Flyway migrations plugin in my project. I could just probably run that and see if everything works. Maven Flyway migrate. Well, hopefully it does what I needed to do. OK, it seems that the inserts passed, and we can probably just check now what's inside the database. Now it's 42 tables for a reason, because now we also have the history table. Let me see. Yeah, there's that. Let's see what's inside. OK, so the two scripts were executed. The init, the seed data, checksums, everything is there. And we, just to check if we have the right data in this machines table. So state is there as well. Great. You have any questions, comments? Maybe you do something differently in your applications, in your projects. Maybe there's something missing in this workflow that you think would be useful.
What if checksums are changing? I mean, if I change my mind, I mean, usually we write migrations first, then apply, and control consistency this way. So how to handle such situation when I change the decision, or it should be incremental each time? Add column, rename column.
I think it should be incremental. At least the Flyway says it should be, and they're very strict about the checksums. What you could do, well, technically, kids don't try it at home. I mean, you go into this table and correct it, or drop some inserts, some data to kind of roll back and replay. But I wouldn't advise it, probably. Yeah, there is a question.
You generated all the data for the entity out of the SQL script. In regards to that, is this support for Lombok as well? That you generated all the getters inside for you?
Yes. So if you have a dependency to Lombok, it will generate the appropriate annotations instead of getters and setters. I just didn't have Lombok in my project right now. OK. So we are ready to move forward, and probably we could start adding some functionality into this thing. We have created the initial script to initialize the database schema. We have the data. We have run the Flyway migrations. We can now move on into the second part, where we could create a new entity, right, and explore the different types of changes in the project in regards to data layer, right? So assume we are building the product line or production line, and we are going to add a new entity. So what we can see here is that, well, one thing, getters and setters, of course, they are missing. Let's add them, because I don't have Lombok, whatever. But we here, the IDE immediately tells you that this entity is not mapped, right? The table, it does not exist, even though like I expect it to exist there. So maybe I want to do something. So I could do alt-enter, for instance, create Flyway diff changes, and say that, like, compare the source of truth is now my model, not the database anymore, at least for this workflow. And please compare to the database and, well, create the migration script for me. So let's see, add production line SQL. And what we see here is that everything is green. It's a safe migration, because it doesn't change anything in the existing schema. It just adds the new table with all the constraints that I want in the well, not so correct location. Let's go there and create. And well, it's done. I mean, like, it was easy, right? So we have the migration. The application is not running, but we can just tell Flyway to migrate, and we will see the new table being added into the database. That's pretty straightforward. Let's see. Is it there? I don't see, like, easier to check here. Yeah, so the migration was run. Great stuff. The other type of migration, we would call it yellow migration, is when you start, let's say, changing something that already exists. So if we go into the machines entity and say, what if we rename the some attribute? In real life, how often do we have to change the name of the column? Not really often, right? Usually it's adding a new column or dropping because, well, in very rare cases. But assume we have this situation. I just want to demonstrate how the tool works. So maybe we call it something like speed multiplier, something like that. Yeah, so it didn't rename the column. So because we are just changing the logical model, and it's safer not to rename the column itself, but assume we want that. So it's going to be speed multiplier. So now we are getting in, like, we are attacking our status quo in the database, and we probably want to generate the migration. So if we create the migration, again, our source of truth is the model, and we are comparing it to the database. And if you look at the result right now, by default, the tool can only guess that it's a rename migration. Currently, it thinks that you're dropping the existing column and adding a new one. But looking at the type of the existing column and the entity itself, it can say, oh, maybe, just maybe, it's a merge that you can do on those changes. And instead of actually dropping and adding, you could do renaming. Yep. Yeah, so that would be the kind of the safe migration. Well, it's safe because we assume that our application code is the only source of truth for this data. And the only application that consumes the data from our database is our application. We cannot always assume that, right? Like, it's probably true for some microservices world, heuristic world, but in the integrations world, you usually have multiple applications attacking the same database. So that's one of the things to account for. Yeah, did not refresh the... Oh, because it doesn't exist in the database. We have to run the migration, of course. Let's do that. Rename. Good. So it's there. Let's check again. Again. Yep. Something to fix. Let's do rename. Great. So we can run the migration again. And it's going to be there. So, and of course, that's a yellow migration, kind of. And of course, there could be also a red migration if we, let's say, we drop some kind of column. Like, let's say there is some redundant column in the factory table, and if we explore the factory table and see, okay, there is a pollution rating for the factory, but in fact it duplicates the logic from the pollution zone, because it's also the same data, same values, and it is kind of duplicated, and logically it belongs to pollution zone instead of factory itself. So we could actually go and modify the entity pollution rating. Yeah, that's the one. So just let's comment it out and comment out or remove those setters as well. So again, the same flow. We actually have to create, not to create, but create the migration. Flyway migration. And it's going to be dropping in column, of course. Great stuff. And move the script to correct location, of course. Remove column. Yeah, typing. Great. So all those steps right now are for application first workflow. So how many of you are developing applications on your own, like single developer team? Okay, most of you are actually working in teams, right? When you work with teams, do you use branches for development? Are they short-lived or they are long-lived? Like short-lived, right? Anyways, like concurrently, like within the team, like you might be doing changes to the application code and to the database structure as well in the different branches. Effectively, it means that you support 2 code bases at once, and when the merging time comes in, what do you do with the data, or with database migration scripts? Has it happened to you?
We need to enumerate them sequentially with this.
Right?
I have an answer how we do this. We block the number in special shared table. So no other engineer.
So you make some intervals, or like you block the number by branch?
Yes, yes. And if for some reason the merging is postponed, we just flip numbers.
Great system. I mean, but the problem could be if you don't synchronize with the rest of the team, right? Let's say you have migration V1, V2, V3. Then the branch comes in, and you do V4, and someone does V4 as well. And then when merging comes in, like merging moment, then maybe the V4 and V4 are different, or attacking like different parts of the application. So the branch should actually respect the main branch. Like your development branch should respect the structure in the main branch, and how then would you adopt your migration scripts? So you actually have to go and check like if the current migration, the current structure of the database is like you should compare the state in your branch and the database that is the main one, not in your branch anymore, right? So when the merging moment comes in, let's say we have 2 databases, right? We have the my development database where I'm developing in a branch, the main database, my database, and then my DB is the one, the ultimate true version of the database. And now I'm kind of merging it, and I have to compare to this main database that is in production. And what do I do? Like I have to generate the migration against this one, and then compare not the model anymore, but my database to that main database, right? So it's going to be DB against DB comparison, and of course I have to check the right connection and see if it generates stuff. Somehow I see a bit more changes than I expected, especially with drop columns, but maybe I selected it in the wrong way. So you have to account for the order, how you select them, like from which one to which one you compare. But the point is that, well, it probably is a solution, like if you have to develop in branches, and then you would have two versions of the database. You would not have, you would not compare the migration files, but you would compare the database instances instead, and generate migrations out of those. Right. Okay. So besides the support for database technologies like JPA or JDBC, and then adding support for migration libraries like Flyway and Liquibase, when you start developing the application layer, some other parts of the ecosystem come into the game, right? And I will not do those changes by hand right now. I will just pull out the, let's say, final version of this application. What was it? Check out the revision. Hey, can you roll back the changes? Let me see. Git reset. Yep. Now I have more entities, right? And I have more application logic. So what is needed when you start adding more code and adding more application logic into the project, and start connecting everything to the persistence layer that you already have in the project, because we started from the database and we were building by layers. We were building the persistence layer, then obviously we start writing the service layer, controllers, APIs, and maybe at the end you add the UI. To move from the persistence layer, you would sometimes use mappers. Like, how many of you are using Mapstruct? Some of you, right? So, although it's not a persistence technology, it is actually related, right? And you would start adding those mappers. Probably, if you are using it, you are using some kind of a generator, the plugin for Maven plugin to generate those mappers, and so on. So I have that in the pom.xml, right? Right there. Yeah, Mapstruct processor. So we want to help you with this kind of situations as well. And there was actually a plugin called, or it actually still exists. The plugins, if you go and find it, it's called JPA Buddy. So a lot of the initial functionality that I was showing already or demonstrating for the Flyway migrations, generating JPA entities, and so on, they were implemented in this plugin. And now slowly, this functionality is actually moving into the IntelliJ IDEA itself. The reason it doesn't move too fast is that when the plugin was developed, it was mostly based on all kinds of flows around wizards, and those wizards are very complicated. So you have to know exactly which checkbox to click and which option to select. And now we are trying to make it a bit more fluent, IntelliJ style, with completions and commands. But one of the functionalities that is still in this plugin, and it's not moved into the main IntelliJ support, is support for Mapstruct. And this is very convenient feature, actually. If you go to some entity, let's say factory, there are some buttons now that are available that come from JPA Buddy. And most of them are already inside most of the functions are already inside IntelliJ itself, but the functionality for creating the DTOs and some of the completions and inspections is still in the JPA body, and it actually is helpful to enable that plugin when you know that you work with Mapstruct, for instance. One of the useful things that I discovered for myself in this plugin is when you generate those entities or the DTOs from the entities, but when you start working with the code and you need to write code that maps something, let's say in this case, we have an endpoint, right? We have an endpoint that was written, for instance, this way, returning an entity, not the DTO, and it was returning the entity out of the controller directly. And I generated the mapper. So generation is not like rocket science there, but then the plugin adds some of the commands into additional commands into the completion dialog so that you can actually smoothly convert your code into something more meaningful by adding this mapper directly. And of course, yeah, changing the type is required for this thing into the DTO. So then it looks more like a native integration than going through those dialogues in the header of the entity. So it's a work in progress. We have seen the workflow from the database, what you can do in IntelliJ right now when you're just starting with the database, and the database is a source of truth. We have seen what is possible right now with the application-first workflow. It's still a work in progress. We are going to add more integrations and migrate some of the functionality from JPA body plugin. And well, I hope it wasn't time wasted for you, and you can get a coffee now. Thank you for coming. And yeah. If